have been tapping for hundreds of years. First discovered by the Iroquois Nation, Native Americans would boil and cook their food in sweet sap in order to enhance their food and the flavors using the maple tree's natural sugars.
As international baccalaureate students, we were tasked with identifying, tapping, collecting, and boiling maple syrup while exhibiting skills in
physics,
biology,
and chemistry
combined.
As we began this assignment, we discovered that our essential initial step was to learn the identifying characteristics of sugar maple, the trees which provide the sap that would become the syrup.
This was after all the snow had fallen.
It's cold.
Our main source of identification, the leaves themselves, had already fallen off of the trees, so we had to resort to different methods to identify them.
Sugar maples are identified by their opposite branching, paired buds, grayish-brown bark with deep ridges, and semi-short stature. Bark identification. So we found this one, and unlike our last finds, it was actually thick enough to tap, which is fantastic. As you can see, the bark is somewhat peeling off because it has these deeper ridges. It's kind of a grayish brown. We'll see what comes out.
After we searched for a few hours, we ended up finding 3 maple trees that met the required diameters.
So what happened, Chris?
Okay, so we have a 33-inch circumference, which means a less than 12-inch diameter.
Measure a thicker part of the tree.
We brought with us spray paint to mark our trees so that we could later come back in the spring to tap them.
Our research process began in November. As the snow began to fall, our maple trees began storing their sap. In the winter months, maple sap is taken up from the roots and stored in the upper levels of the tree. The harsher the winter, the more sap is brought up, and thus the greater yield comes springtime.
Please see the following very high budget, very high production value educational video on how we put the taps in the trees. Alright, we're tapping a tree.
It's our first tap for the season.
And we have these taps and a drill. This is a 5/16 of an inch bit. You gotta drill into like a nice looking part of the tree, ideally on the south side because it's facing the sun during the day, so it has more temperature fluctuation. Also, like as low down as you can get it. Put it in. If I had a hammer, I'd give it a few whacks. The tap doesn't have to go all the way in. We have this bucket. We already drilled a hole in the bucket, put the tubing in the bucket, leave the bucket in a good spot.
And then we're all set.
We collected sap twice a week for a month, which involved many trips down to the bus garage and many weird looks from the bus drivers. But we collected a total of 40 gallons of sap in 30 days for an average of 1 1/3 gallons per day.
Cheers.
All right.
Cheers.
After we had collected our buckets of sap, we had to bring each bucket to one of the chemistry lab rooms to actually measure our densities, mass, and volume.
100 milliliters down. This entire bucket to go.
To calculate the density, we were able to take measurements of mass and volume and extrapolate that calculation to the entire sample. So what we did was we weighed the graduated cylinder before it had any sap in it, and then in the lab we carefully measured out 100 milliliters of the sap in a graduated cylinder, and by subtracting the final mass and the initial mass, we were able to figure out the mass of the sap itself. And then using that mass, we could divide that by the 100 milliliters in the sample to calculate the density of that small 100 milliliter sample. And then assuming that the entire bucket of sap had a uniform density, we could extrapolate that density measurement while also using an estimation of the total volume of the sap. What we did was we put a ruler into the sap to figure out the depth, and then using the diameter of the bucket, we could calculate the total volume, and using the calculated volume, we could take that and then the calculated density of the sample to figure out ultimately the mass of the entire bucket of sap.
Both Chris and Mrs. DeJohn boiled syrup at their houses. To process maple syrup, you first have to filter the sap, as a lot of debris from the forest ended up on our buckets. Next, it's put over a fire, outside, and boiled until it reduces to a golden brown color. This usually takes a day. By nighttime, it's ready to be taken inside and boiled over the stove. Boiling times and temperature will vary based on the grade of syrup you prefer. It's usually around 219 degrees Fahrenheit. Grade does not equal quality. Rather, it's the color and flavor of the syrup you prefer. Mrs. DeJohn demonstrated a variety of grades, and over a few weeks, everyone's syrup would be ready.
A well-known and long-standing debate between natural and artificial syrup has stood the test of time. High in artificial and processed sugars, but low in cost, artificial syrups are a tempting alternative to organic maple syrup. However, the nutritional benefits of real maple syrup surely support the cost. Real maple syrup contains small amounts of calcium, pantothenic acid, riboflavin, potassium, and magnesium, which are all beneficial for your health. Most advantageous, however, is the presence of bioactive phytochemical. This substance is known as a phenolic, a plant compound that protects against cancer. Despite the nutritional benefits it provides, the sugar content is still extremely high. Therefore, maple syrup is a prime example that too much of a good thing is not really a good thing at all.
Over the past few months, we've been able to collaborate with different sciences to produce a pretty sweet outcome. We learned a lot from each other, and I think this is a project we can all remember.